The universe is a cosmic highway with countless objects zipping past Earth at incredible speeds. On July 17, 2025, asteroid 2022 YS5 made a close approach to our planet. Not a disaster, but a scientific opportunity. This event was a real-world test for planetary defense and a reminder of our dynamic solar system. Astronomers worldwide track these near-Earth objects, ensuring close flybys remain just that, flybys. The name 2022 YS5 marks its discovery year and follows a systematic naming convention. Since its discovery, astronomers have refined its orbit, predicting this flyby with precision. Let's explore what asteroids are, the specifics of 2022 YS5 and why planetary defense matters. This is the reality of living on a planet shaped by cosmic encounters. Vigilance is key. On July 17, 2025, asteroid 2022 YS5 silently passed Earth, tracked by observatories worldwide. To the public, it was invisible, just a faint blip in powerful telescopes. In astronomy, a close shave still means millions of kilometers away. YS5 passed well outside the moon's orbit, posing zero risk. Years of observation and complex calculations ensured its safe passage. Each flyby is a chance to test and refine our detection and tracking systems. Events like this spark curiosity and allow scientists to explain planetary defense without alarm. The data from YS5 will improve our future readiness. Looking up and paying attention is a responsibility we all share. To understand YS5's significance, we need to know what asteroids are. They're leftover building blocks from the solar system's formation, orbiting mostly between Mars and Jupiter in the main asteroid belt. Jupiter's gravity can nudge some onto new paths, turning them into near-Earth objects, or NEOs. NEOs are the focus of planetary defense, as they occasionally cross Earth's orbit. Asteroids vary in size and composition. Some are solid rock, others loose rubble, some metallic. Studying them reveals clues about the early solar system. Earth's history is marked by asteroid impacts, including the one that ended the dinosaurs. While large impacts are rare, smaller ones can still cause regional damage. Tracking and understanding these objects is essential for our safety. It's not just science, it's survival. Asteroid 2022 YS5, a celestial wanderer, is estimated to be about 13 meters wide. To put that into perspective, let's consider some familiar objects. This space rock was discovered relatively recently, highlighting the ongoing efforts to catalog near-Earth objects. Think of it as roughly the size of a city bus. Or perhaps a small house, the kind you might find in a quiet suburb. This gives you a tangible sense of its dimensions as it hurtles through space. In asteroid terms, that's considered small, but it's still significant enough to warrant our attention. Size isn't everything when it comes to these cosmic travelers. If an asteroid of this size entered Earth's atmosphere, it would likely burn up due to the intense friction. This fiery entry would create a spectacular fireball, a dazzling display across the sky, but likely cause relatively little damage on the ground. YS5 traveled at an astonishing speed of 8.1 kilometers per second. That translates to over 29,000 kilometers per hour, which is approximately 24 times the speed of sound. Imagine the forces at play at such velocities. Even relatively small objects traveling at these speeds possess immense kinetic energy, capable of releasing a significant amount of energy upon impact. To illustrate this, consider the 2013 Chelyabinsk meteor. It was slightly larger than YS5. That particular meteor exploded in the atmosphere with the force equivalent to approximately 30 Hiroshima bombs. The energy released was truly staggering. The resulting shockwave caused widespread damage, including broken windows, and tragically injured over 1,000 people. This event serves as a stark reminder of why even seemingly small asteroids are taken seriously by scientists and space agencies worldwide. Fortunately, YS5's trajectory was well calculated and understood, posing absolutely no threat to our planet. However, it serves as a perfect example of the type of near-Earth objects that we need to actively find, carefully track, and continuously monitor. Current estimates suggest that there are likely hundreds of thousands of similar asteroids lurking out there in the vast expanse of space, many of which remain undiscovered. Therefore, every new detection of these near-Earth objects represents a significant victory for planetary safety and our ongoing efforts to protect our home. The recent close approach of asteroid YS5 has sparked a lot of interest, and understandably so. When we say close approach in astronomical terms, what does that really mean? Let's put it into perspective. YS5's closest approach to our planet was approximately 2.97 million kilometers from Earth. That's a substantial distance, but to truly grasp the scale, we need to compare it to something familiar: To give you a better sense of scale, that's over 7 times farther away than the Moon is from Earth. The Moon, our constant companion in the night sky, orbits us at an average distance of about 384,400 kilometers. So, imagine that distance, and then multiply it by more than 7. That's how far away YS5 was during its closest approach. It highlights the vastness of space and the distances involved in these celestial events. Let's try another analogy to bring this into even sharper focus. Imagine shrinking the Earth down to the size of a cricket ball. On that scale, the Moon would be about 24 feet away from the cricket ball. This gives you a tangible sense of the Earth-Moon system's proportions. Now where would YS5 be on this miniature scale? It would pass by at a distance of approximately 180 feet. This considerable distance ensured that the flyby was completely safe for our planet. There was never any risk of impact, and the asteroid posed no threat to Earth. The ability to predict these close approaches with such accuracy is a testament to the hard work and dedication of astronomers and scientists around the world. Once an asteroid's orbit is well observed and enough data is collected, its path can be predicted with a high degree of precision, often years or even decades in advance. This allows us to assess any potential risks and prepare accordingly. It's important to understand the terminology used when discussing these objects. The term near-Earth object, or NEO, refers to any asteroid or comet whose orbit brings it within 50 million kilometers of Earth's orbit. This doesn't necessarily mean it will hit Earth, just that it comes relatively close in astronomical terms. YS5 is also classified and discussed as a potentially hazardous asteroid, or PHA. This designation might sound alarming, even though it's actually smaller than the official size threshold that usually warrants that classification. However, potentially hazardous is primarily a scientific label. It simply means that the object's orbit brings it close enough to Earth that it warrants careful and ongoing monitoring. It's a call for vigilance, not an indication of an immediate threat. Asteroid orbits are not static. They can change over long periods of time, sometimes over centuries, due to gravitational interactions with planets and other celestial bodies. This is why early identification and tracking of these objects is so crucial for long-term planetary defense. By diligently tracking these objects now, gathering data on their orbits, sizes, and compositions, we provide future generations with ample warning time to take action if a potentially hazardous object is ever found to be on a collision course with Earth. The YS5 flyby serves as a great example of our planetary defense system working exactly as it should. We were able to identify the asteroid, accurately track its trajectory, and predict its close approach. And most importantly, we were able to verify its safe passage, confirming that it posed no threat to our planet. Continuous monitoring and improvement of our asteroid detection and tracking capabilities are essential. Vigilance today is what ensures safety tomorrow, protecting our planet from potential future threats. The YS5 flyby highlights the science of planetary defense. It's not about Hollywood heroics, but careful, coordinated work by scientists worldwide. The first step is detection. Survey telescopes scan the sky for moving objects. Once found, the Minor Planet Center coordinates follow-up observations to calculate orbits. Next comes tracking and characterization, refining the orbit and learning about the asteroid's size, shape, and composition. Knowing what an asteroid is made of is vital for planning any future deflection mission. If a real threat is found, mitigation strategies like NASA's DART mission, crashing a spacecraft to nudge the asteroid, can be used. Even a tiny change in speed, if done early, can make an asteroid miss Earth. International collaboration and preparation are our best defense. Finding and tracking asteroids relies on a global network of survey telescopes. These wide-field telescopes scan large areas of the sky, looking for moving dots among the stars. Once a new object is spotted, follow-up observations and radar studies refine its orbit and reveal its shape and size. Radar provides the most precise measurements, crucial for predicting future paths. Space-based telescopes like NEOWISE can spot fainter objects and those hidden by the sun's glare. The upcoming NEO Surveyor mission will boost our detection capabilities even further. The Minor Planet Center acts as the central hub, sharing data worldwide. This open, collaborative approach keeps our knowledge up to date and our planet safer. Every asteroid flyby is a real-world test for planetary defense. Scientists compare predictions with actual data, refining their models and understanding subtle effects like the Yarkovsky effect. Close passes let us study asteroids up close, revealing their composition and structure, vital for any future deflection mission. These events also test international coordination and communication, ensuring everyone is on the same page. Each flyby adds to our knowledge of the near-Earth object population. By studying these encounters, we improve our risk estimates and justify future survey missions. Every flyby makes us better prepared. The passage of 2022 YS5, a relatively small asteroid that zipped past our planet, was ultimately a quiet event. It didn't pose any threat, and its journey through our solar system was largely uneventful. But its flyby served as a powerful symbol, a potent reminder of our progress in understanding and mitigating potential cosmic threats. It highlights how far we've come in our ability to observe, track, and understand the objects that share our celestial neighborhood. A century ago, an object like 2022 YS5 would have likely gone completely unnoticed. We simply lacked the technology and infrastructure to detect such a small object at such a great distance. It would have remained a silent, unseen wanderer in the vast expanse of space. Today, thanks to advancements in telescopes, radar technology, and sophisticated computer algorithms, we are able to track and predict the trajectories of these objects with remarkable precision. We can calculate their orbits, assess their potential risk, and even plan for potential mitigation strategies. This is the story of planetary defense in action. A global effort involving scientists, engineers, and policymakers all working together to protect our planet from potential asteroid impacts. It's a story of dedicated astronomers acting as our sentinels, constantly scanning the skies, identifying potential threats, and building a metaphorical shield for Earth, one observation at a time. Each new discovery, each close flyby, each piece of data collected, adds to our understanding of the near-Earth object population. And with every advance, we move the threat of a catastrophic asteroid impact from the realm of science fiction to a manageable reality, a challenge we can address with knowledge, technology, and international cooperation. We're the first generation in human history with the capability to prevent a major asteroid impact, to actively defend our planet from a cosmic catastrophe. This is a remarkable responsibility, a testament to our ingenuity and our commitment to safeguarding the future of humanity. The dinosaurs, those magnificent creatures that once roamed our planet, had no warning of the asteroid that ultimately led to their extinction. We do. NASA's DART mission, a groundbreaking demonstration of asteroid deflection technology, proved that we can, in fact, alter the course of an asteroid. And ongoing surveys conducted by observatories around the world are constantly improving our ability to find potentially hazardous asteroids, giving us ample time to prepare and respond. Continued investment in these vital programs is absolutely key to ensuring our long-term safety and security. It's an investment in the future of our planet and the generations to come. So as we look up at the night sky, let's do so with a sense of wonder, but also with a sense of preparedness, knowing that we are actively working to protect ourselves from the potential dangers that lurk in the cosmos. Our future is undoubtedly safer under a watched sky, a sky constantly monitored by dedicated scientists and advanced technology. Thanks to the ongoing efforts in planetary defense, we are increasingly ready for whatever the cosmos may send our way, equipped with the knowledge and tools to safeguard our planet and ensure a brighter future for all.